Choose the correct alternative. If the zero of potential energy is at infinity, the total energy of an orbiting satellite is negative of its kinetic or potential energy. So if we look at part A, there's a planet and there is a satellite revolving around this planet in some orbit. So the total energy of this particular satellite will be the sum of potential energy and the kinetic energy. We already know the velocity of this satellite is going to be under root gm by r, and r is the radius of the orbit, and from this we get the kinetic energy to be equal to half m into gm by r, which is gmm by 2r. And we already know the potential energy is minus gmm by r. So the total energy will be equal to the sum of these both potential and kinetic energies, gmm by r plus gmm by 2r, and this is going to be equal to minus gmm by 2r, and this is minus of kinetic energy. So total energy is the negative of kinetic energy of the satellite. Now let's look at part B of this question. The energy required to launch an orbiting satellite out of Earth's gravitational influence is more or less than the energy required to project a stationary object at the same height out of the Earth's influence. So in this part we need to compare two things. The first thing is that the energy required to project a satellite orbiting, and the second one is the energy required to project a satellite which is at the same height as that of orbiting satellite out of gravitational influence. So in this case it is stationary. So for the first part, as the satellite is orbiting, we just saw that total energy is minus gmm by 2r, and the energy required to project this satellite out of the gravitational influence will be minus of total energy, and this is equal to gmm by 2r. Whereas in second case, the satellite is stationary, so the total energy will only be the potential energy, and the potential energy will be equal to minus gmm by r. So the energy required to project this satellite out of Earth's gravitational influence will be minus of total energy of this satellite, and this is equal to gmm by r. So we need lesser energy to project an orbiting satellite than that of the stationary satellite. So u1 is less than u2. So in this case it is less.